Hello, our viewers and our subscribers. Welcome back to our channel where we talk about different aspects of the life of the car, the life on the road, and transportation in general. Earlier on, we were talking about ABS systems, and now we are talking about their relative traction control systems. All these are to do with the operation of the wheels and how efficient modern cars have become. Also, what happens if these systems are not in good condition? Engineer Ivan Chibuka is going to take us through this session, and we are glad to always learn a thing or two from him. Welcome, Engineer Ivan.
Yes, thank you very much, Alan. My fellow Motormouth, you have mentioned, today we are going to talk about traction control systems on cars. What they are, what they do, how they do it, and what may happen if they don't operate normally. And how better is a car with traction control. How much better is it than one without? Things of the sort. Once again, I'm going to use the presentation. To make things easier to visualize. Let me know if you can see.
Yes, I can see it.
Yes, traction control is very much related to anti-lock braking systems that we discussed in the previous video. So if you haven't seen our video on ABS, dear viewer, I urge you to go back and watch that first, because traction control will become easier to understand if you do. Yeah, so the steerability of a vehicle is not only lost when the wheels lock up on braking. That is something we discussed. We discussed locking up of wheels or tires in the previous video about ABS. The same effect of locked wheels arises if the wheels skid when driving off or when starting off under severe acceleration. Our roads here in Uganda are not good, so especially when you go to upcountry areas which are not paved, we encounter this very much, especially when it rains. So many of you can relate. Electronic traction control has been developed as a supplement to ABS, to anti-lock brake systems. This control system prevents the wheels from spinning, this time not when stopping, but when moving off, or when accelerating sharply on the move. In this way, an individual wheel, which is spinning, is braked in a controlled manner. Without the input of the driver is only stepping on the throttle to accelerate, but you'll find out now that during traction control, some wheels are braked, not all, but those which need to be braked are braked. If both or all of the wheels are spinning, the drive torque is reduced by means of an engine control function. This control is initiated by the traction control module, as we shall see. Traction control is not normally available on a car as an independent system, but in combination with the anti-lock brake systems or an anti-lock brake system, ABS. This is because many of the components required with the traction control are the same as the ones for ABS. Traction control only requires change in logic in the ECU and a few extra control elements such as control of the throttle. That's why for modern cars with the drive-by-wire, the car, the engine computer and the brake computer needs to be communicating in real time to give each other instructions and to take data back and forth, information back and forth. Traction control will intervene to maintain stability, like we've just discussed. You can start off. Alan, have you ever started and the car started zigzagging in bad weather or on slippery roads? Traction control,
Yes.
traction control manages that. If you have a car with the traction control, it's very rare that you get into a situation where the car is fishtailing when you're accelerating on start off. So this will reduce the yawing moments. The yawing moments are what I described, the fishtailing, the sideways movements. It will also provide optimum propulsion at all speeds, reduce driver workload because it prevents you from having to react to the car doing manyanga as you are taking off. An automatic control system can intervene in many cases much more quickly and precisely than the driver of the vehicle. I don't want to say drivers are being dumbed down here, but the idea is to make driving safer, make us all safer on the road. You can have an experienced driver managing to go through a slippery part of the road because of their skill, but then an unskilled driver losing control because of lack of traction control and lack of skills can crash into the skilled driver. So these systems make all of us safe on the road, even pedestrians, not only people using the cars. So this allows stability to be maintained at a time when the driver might not have been able to cope with the situation. The schematic on the screen now shows you, it gives you an idea of how the system is related. You have 4 wheels at the corner of each vehicle, rear right wheel, rear left wheel. I don't know if you're following my cursor. Front left wheel, front right wheel. And then they are all connected up because you have wheel speed sensors sending information to the traction stroke ABS control module. And then the ABS stroke traction control module speaks to the transmission module. I mentioned this interconnectivity in the previous video about ABS. In future, we shall discuss exactly how these vehicles communicate, or rather how these modules communicate. Yeah, but just know that the traction control module will also talk to the engine control module to control the gearbox the right way. It may even need to change gears as you are sleeping without your input. And then it will also retard the timing on the engine. Again, to achieve precise control, to hand back control of the direction of the vehicle to you. It will intervene without your input or without your knowledge, but the bottom line is your driving will be safer. So how does traction control operate? Control of tractive force can be through a number of methods. You can control the throttle via an actuator, which can move the throttle, or if the vehicle employs a drive-by-wire accelerator. Most cars from around 2002 or 1 have this now, have the drive-by-wire accelerator pedal system. So this will then control, in conjunction with the engine management unit, it will control the torque coming from the engine. The throttle control will be independent of the driver throttle pedal position. So if the if the computer realizes the car is fishtailing as you are setting off, regardless how hard you press the throttle, the vehicle, the ABS traction control module will instruct the engine control module to take away some torque. In other words, you, the driver, will lose some control over the engine torque or RPM or whatever other method is using to control the torque until the vehicle is stable again. So temporarily, you may feel as if you've lost control of the accelerator pedal. So this method alone is relatively slow to control the engine torque. The other method is through ignition control. If ignition is retarded, if ignition of the fuel is retarded, the engine torque can be reduced by up to 50% in a very short space of time. So timing is adjusted by a set ramp from the ignition map value that is stored in the memory of the engine computer. And then there is a braking effect where if the spinning wheel is restricted by brake pressure, the reduction in torque at the affected wheel is very fast. Maximum brake pressure is not used, of course, to ensure that passenger comfort is maintained. I would love to go into limited slip differentials and how they help, but unfortunately, we don't have time for that here. But just know, Alan, have you noticed when a car, let's say a car has rear wheel drive, if the rear axle has one of the wheels off the ground, or it is on slippery ground, the most obvious case is where one wheel is hanging in the air. Have you noticed the other wheel, however hard you press the accelerator pedal, have you noticed the other wheel stops spinning also? The one which is in the air spins, but the one which is on the ground stops. Have you noticed that?
I'd never taken keen interest, but sounds
You,
interesting.
yes, that is what normally happens because of the way the differentials are made. The differentials are made such that one wheel can travel faster than the other when you are cornering. You know, when you are cornering, the wheel that is on the outer side of the corner travels a longer distance than the one inside the corner. So they are not traveling exactly the same distance. If the axle was fixed, then there would be, you can imagine there will be some dragging of the wheel to compensate for the different speed. So to prevent that, they allow some slipping in the differential so that these wheels corner at different speed. But that same mechanism is what now leads to when one wheel does not, on the same axle, when one wheel is not, does not have grip on the ground, it spins and the other wheel totally stops as if it is lame. You get? So to overcome that, traction control will send some braking power to stop the wheel which is spinning, to slow down and wait for the other wheel which has stopped, which is actually on the ground, and then slowly the vehicle will get out of that fix. So with the cars which have traction control, you will notice that it will be very rare to be stuck in muddy conditions. People used to say in the past, Benz, BMW, ziserera mukyalo. The newer ones rarely, that rarely happens to the new ones because they have traction control. They may not even be four-wheel drive or all-wheel drive, but because they have traction control, they overcome that handicap of the limited slip differentials. I'm sorry to divert into this, but I think I needed to explain it briefly so that it makes sense here what the traction control is doing once you get into slippery conditions. Anyway, the traction control operation is as follows. A sensor determines the position of the accelerator pedal and taking into account other variables such as the engine temperature and speed. For example, the throttle is set to the optimum position by a servo motor. When accelerating, the increase in engine torque leads to an increase in driving torque at the wheels. This is normal driving when you don't have problems with the surface of the road. To achieve optimum or acceleration, the maximum possible driving torque must be transferred to the road. This is what the gearbox and the differentials ensure. If driving torque now exceeds that which can be transferred, what I mean here, if too much force is arriving at the wheels, too much turning force is arriving at the wheel, then can be handled by the interface between the tire and the road, for example, in slippery conditions. I don't know if I'm using very technical words, but I don't know how to put it better. I'm trying to make it simpler. Basically, the driving torque exceeds that which can be transferred to the ground. Then wheel slip will occur and the vehicle will start slipping, fishtailing. It will occur at least on one wheel. That is why in slippery conditions, it is not wise to floor the pedal. I see a lot of drivers making that mistake in slippery conditions, especially matatu taxi drivers. That's one big mistake. I know you can try to use momentum where you drive at some speed from a dry part of the road and you try to drive through the slippery part quickly by using momentum. But once stuck, if the vehicle stops for whatever reason, and you are still in the slippery part, flooring the gas pedal is useless, especially if you have traction control. If you have traction control, the traction control will take over, and even if you floor the gas pedal this time, the computer will ignore your inputs and do what is required to try to get you. It will reduce the RPM and the torque to try to get you out of the bad spot. The result of this is that the vehicle becomes unstable when you have that loss of traction on one or more wheels. Traction control operation continued. When the wheel spin is detected by the computer, the traction control computer, it is also the same computer that controls ABS. How does it detect it? It looks at the wheel speed sensors, which we discussed in the ABS video. For those who haven't, please go back and watch the ABS video first to understand this better. Anyway, the throttle position and ignition timing are adjusted. But better still, the brakes are applied to the spinning wheel. This not only prevents the wheel from spinning, but acts to provide a limited slip differential action. This is something I was discussing about 2 slides back. This is particularly good when driving on a surface or a road with varying braking force coefficients. What I mean here is one wheel is on solid ground, the other is in a slippery puddle or an ice patch or a muddy patch. Or you have deep potholes where the wheels are not resting on the ground with the same force. Alan, I don't know if I'm being too technical. I'm trying to use simpler words for you to understand this system. So when the brakes are applied, a valve in the hydraulic motor assembly moves over to allow traction control operation. This allows pressure from the pump to be applied to the brakes on the offending wheel. Again, for you to understand this, you need to have watched the ABS video. Please do. The valves, in the same way as with ABS, can provide pressure buildup, pressure hold, and pressure reduction. This all takes place without the driver touching the brake pedal. Because you are trying to drive off, so your foot is on the gas pedal. The summary of this is that the braking force must be applied to the slipping wheel so as to equalize the combined braking coefficient for each driving wheel. Yeah, again, the controller looks exactly like that in most cars. You have the controller in black, and then the silver aluminum part is the modulator. Yeah, thank you very much for your interest and sticking through to the end of this presentation. Alan, if you have any questions or comments, I'll now take them.
Thank you very much for that explanation on traction control. I loved the examples you've used about the cars skidding, especially when they go to the villages. I think this is something many can relate to because they see it a lot when there is a function and then so many cars come. Some of them park on the grass, and maybe after some time there's some rain. So by the time you parked and the time of you leaving, the road or the surface, in this case, the surface has
Sometimes they
changed.
have to drive through ditches in Salo.
Yes. There's even that where there are those ditches, the trenches along the road where someone tried to park. Generally, conditions that they are not familiar with, given their urban life. And when they try to get out, it becomes a problem. People either have to come and push the car, or someone has to come and advise, say, soko lindeko, don't do this, do this, or turn this side, or don't over accelerate. So lots of wise people start gathering, some even who don't even have cars. But because they have seen you who is inside it, you have been defeated.
Yeah.
Yeah, so understanding some of these things like traction control and how they work in such situations is really, really very important.
Yeah, a lot of us have cars with the capabilities that we don't know about, or we see them, we misunderstand them. And we don't know when they come in handy, we don't know how to take advantage of them. Yes.
Especially in this era of automatic cars, most people just do the bare minimum. They operate the car like a microwave. You know how people operate the microwave.
Yeah.
They put in the food, the same button for time,
Yeah.
and press the one for until
They
the
never
food is cooked.
explore all the other options of defrost. What?
They don't know all the other ones, including myself. I just do
I'm
that
one of
same
the
way.
I'm one of the guilty ones. I just know one mode. If I can figure out how to increase the time, if I get the food out and it has not heated well enough, I just add the time and repeat the process.
Time. Mm. So
Yes.
it is the same scenario now with a lot of these automatic cars. People just know parking, reverse, and drive. They don't want to figure out anything else. So when they are stuck in some of these unfamiliar situations, they are totally clueless.
And
And that's why
interestingly, most of the information that I'm giving you sounds technical, but you find it in many of the owner's manuals. Many people
yeah, but we
buy cars, but they don't read the owner's manual. I admit we have a lot of Japanese imports, so the owner's manuals, many of them come in Japanese, but it's also very easy to Google and go and find the English version of that same manual. We mostly buy used vehicles here, so I think it is quite easy to find an owner's manual for any 5, 10-year-old car.
I think there are two problems here. One, we have become a generation that doesn't want to touch those manuals. Because you remember back in the day when you would buy a TV or a radio, you would spend like 2 hours reading the manual before you do anything.
Yes.
But now, because of, I think, the era of mobile phones, anything we buy now, we just switch on and figure out things along the
Yeah.
way.
And
We are
when we
interested.
fail, we are either going to go to TikTok or YouTube to find the content. Yeah, but that's why we have come on YouTube and we are trying to get you this information. But most of this
Absolutely.
information we are giving you, by the way, is in your manuals. You have it already. But it's okay for us. We can sit here and give it to you in the format you prefer.
Yes. So yeah, thank you very much for breaking down these concepts.
Mm.
I cannot stress enough how they are important and how anyone who is interested in knowing these things should take time and check on the channel, watch all some of the other videos, ask questions, comment, like. We are here to help each other.
Yeah, this content is for you especially. Actually, we are not really targeting guys who fix cars. We are mostly targeting people who own and drive cars. The average vehicle user. Sometimes we are pained when you guys have problems with the cars, problem that could have been avoided. A few weeks ago, I have a friend whose engine overheated, but the signs were there a week prior. A warning light was coming and going, a red temperature light. It was coming and
Mm.
going. But they continued using and this is someone with whom I've been sharing the links to these videos. So the vehicle was taken to the garage. I think it is still there. And they were given a bill of about 2.8 million to fix that car. Basically to change the engine because it's a Toyota Noah with the 1AZ. Those engines are notorious. Once you open them up, putting them back, they will run, but they have issues. They develop other behavior. You may actually fix the overheating problem, but it will develop other drivability issues. Usually the best thing is to get a new engine altogether. But this is someone that I know I had pointed in the direction of this channel. The first videos we made, Alan, you remember, they were about the engine mechanical side of things, just the basics. We also made a video about the engine cooling system. So I was sad when I heard that they had this problem. So please spread the word. If you watch the video and you have people you think may benefit from this content, please share it. Don't assume that everybody watches that for now. Please spread the word around. Move the links. You can like and then also subscribe so that with every new video that we publish, you get notified right away, and then you set a time to watch it. You don't always have to watch it the moment it comes out. Many of us have hectic schedules, but once you get a notification, you know, I need to create time to watch this content. Yeah. Thank you very much, Alan, for your time.
You're welcome.